Hello everyone, welcome back. So we continue from where we ended in differentiation. So in this video, we'll be looking at the differentiation involving e raised to something. All right, so e is called Euler's number, or I don't know, other people would pronounce it differently, but I pronounce it as Euler's number, e. So e is actually a constant. Yeah, I won't talk about constant that much, but let's talk about differentiation involving this e. All right, so before I begin, don't forget to like and subscribe. This is Mr. Sen. All right, let's begin. All right, so this form of differentiation is quite easy to understand. Say you have a function f of x, and then f of x is equal to e raised to something. So to find the derivative of the function, be mindful of this and don't forget what I'll say. Given f of x is equal to e to the something, the derivative of e to the something will be the derivative of something times e to the something. The derivative of f of x equal to e to the something is the derivative of something times e to the something. Don't forget this. It's very important. If someone says, hey, hi, how are you? Just say e to the something will always be the derivative of something times e to the something. Always answer everything with this. Hey, how's been your day? E to the something is equal to the derivative of something times e to the something. All right, let's try and understand this now. How do we understand this now? Let's understand this with a few examples. Remember, if f of x is equal to e to the something, then f prime of x will equal to the derivative of something times e to the something. All right, hope it's clear. Now, let's look at examples. Let's look at example number 1. Let's say f of x is equal to e to the power 5x. Now, how are you going to differentiate this? Remember, the derivative of e to the something, here the something is 5x. Your f prime of x should be the derivative of something times e to the something. Now, this is what we're going to do for accuracy's sake. Let p equal to the something. And now something in this case is what? 5x. Then differentiate p. Whenever I differentiate in any variable, whatever it is, say a. If you want to differentiate a variable a, just say a prime. B, b prime. C, c prime. D, d prime. E, e prime. All these are derivatives of a. This is a derivative of a, derivative of b, c, d, and e. So given any letter, be mindful of this. So here you are trying to assume that p is something. So remember, it should be the derivative of something. So let's find the derivative of something here. So it's going to say p prime is equal to, remember, the derivative of a number. We said if f of x is equal to ax, provided that the power is 1, then f prime of x is just equal to what? A. So here the derivative will be what? Yes, 5. So remember, it should be the derivative of something. So the derivative of something is p prime. So p prime times e to the something. What's the something? It's 5x. So now, therefore, f prime of x will now be, what is p prime? P prime is 5 times e to the 5x. This is the same as one writing as f prime of x being equal to 5 e to the 5x. And that's the derivative. As simple as that. All right, let's jump to example number 2. So we'll be using the sum technique. So given f of x being equal to 3 e to the 5x, what are we going to do? Do the same thing. Find your data and let p equal to what? Something. In this case, the something is 5x. Find the derivative of something. So say p prime will be what? Yes, 5. So remember, f prime of x will be the derivative of something, which is p prime, times e to the something. Now you are having 3. So just say times 3 to the e 3e to the 5x. So now f prime of x will be equivalent to p prime is 5 times 3e to the 5x. So this can also be written as 3 times 5 times e to the 5x. So f prime of x is equal to 3 multiplies the 5, and you get 15 e to the 5x. And that is your derivative. Hope it's clear. Let's move on. Since you are getting the hang of it, let's try something a bit, just a bit interesting. So y is equal to e to the 12 over x cubed. Alright, so you can pause this video and try. Alright, let's resume. So data. Remember, e to the something, the derivative will be the derivative of something times e to the something. So let p equal to what? Something. In our case, what is something? Something is 12 over x to the third. Let's differentiate p. But before we differentiate, let's put it in a way we can understand. So p is the same as 1 writing as 12 times x to the minus 3. So in this manner, we can differentiate easily. So p prime will be equal to the power multiplies the coefficient of x. Remember the power? Alright. Negative 3 times 12 times x to the minus 3 minus 1. So p prime is equal to 3 multiplies the 12. What do you get? Yes, negative 36 x to the minus 4. So this is the derivative of something. So y prime is equal to the derivative of something, which is p prime, times e to the something, 12 over x cubed. So y prime is equal to derivative of something, which is minus 36 x to the minus 4 times e to the 12 over x cubed. So y prime can also be written as negative 36 x to the minus 4 e to the 12 over x cubed. This is your answer. Another would want to write it as this. Y prime is equal to negative 36 over x to the 4th power times e to the 12 over x cubed. And this is your final answer. If you got this, then it's a very good thing. If you didn't, there's always another time. We'll still get it right. Let's keep on practicing to get better. Let's move on to another example. Example number 4. Given that y is equal to e to the 5th over root of 3 x to the 4th, let's find the derivative, which is y prime. Remember, e to the something is always the derivative of something times e to the something. So let p equal to what? Something. And our something in this case is the power of e, which is 5 over cube root of x to the 4th. So before we differentiate this, remember, just a recall, if you have y, let me not say y, if you have this, you can always reconvert this. Remember, this is the root, this is the base, and this is the power. So this can also be written as the base of a, the power of b, and the root of what? C. So let's try and do that. So p is equal to 5 over x, 4 over 3. This can also be written as 5 times x to the minus 4 over 3. And this can also be written by another as, no, let's just consider it like this, and then let's try to differentiate. Alright, so let's find the derivative of p. So we say p prime is equal to the power multiplies the coefficient, so it's minus 4 over 3 times 5 times x to the minus 4 over 3 minus 1. We can do a quick data here and say, what is minus 4 over 3 minus 1 over 1? Common denominator is 3. 3 into 3, that's 1, times 4, it's negative 4. Maintain the sign. 1 into 3, that's 3, times 1, That's going to give you 3. Minus 4 minus 3 is minus 7 over 3. This implies that p prime is going to be equal to 4 times 5 gives you a negative 20 over 3 times x to the power of minus 7 over 3. And this is the derivative of something. Alright, this is great. Alright, let me just erase this part, this portion here. Alright, so let's move on. Now that we have the derivative of the something, remember, this will now be p prime, which is the derivative of something, being multiplied by e to the something, which is 5 over root of 3 x to the 4th power. Now, remember, what is p prime? So we say y prime is equal to the p prime, which is negative 20 over 3 times x to the minus 7 over 3 times e to the 5th power over root of 3 and base of x to the power of 4. So this is your final answer. We can polish it up and say, okay, y prime is going to equal to negative 20, then say over 3 root of 3 x power of 7 times e to the 5th over root of 3 x to the 4th, just like that. And this will be your final answer. Others would also want to write it in a different way, as y prime is equal to negative 20 times e to the 5th over root of 3 x over 4, sorry, x over x to the 4th, so I was supposed to say, over 3 root of 3 x to the 7th power, like that. And that will be your final answer. I hope it's clear. Don't forget, the derivative of e to the something will always be the derivative of something times e to the something. Hope it's clear. Let's move on to another example. Should be example number 5. Alright, example number 5 says this. F of x is equal to 2e to the minus 2x squared plus 4x plus 7. So, find f prime of x, this will be equal to, just collect data, let p be equal to negative 2x squared plus 4x plus 7. Then find the derivative of p. This one is an easy one. So p prime will be equal to what? The power multiplies the coefficient, so you get a minus 4x plus 4. You get a hang of it now. Alright, so remember, the derivative of e to the something will always be the derivative of something times e to the something. So it's going to be p prime times 2 e to the something, which is minus 2x squared plus 4x plus 7. Then f prime of x will now be equal to this p prime. It's minus 4x plus 4 times 2 times e to the minus 2x squared plus 4x plus 7. Now, we can say f prime of x is now equal to 2 multiplying negative 4x plus 4 times e to the minus 2x squared plus 4x plus 7. The 2 4's it out by multiplying all the values within the parentheses, and you have f prime of x being equal to 2 times minus 4x, it's minus 8x, 2 times 4, that gives you a positive 8, times e to the minus 2x squared plus 4x plus 7. This will be in brackets, and this will also be in brackets, because you're having an expression with another expression. So this is your derivative. Do not forget that. Alright, so let's try example number 6. F of x is equal to e to the 4x squared plus x. Alright, you can pause the video and try. See if you can get it. Alright, let's begin. So, we collect data, because we know that e to the something always be the derivative of something times e to the something. I don't really want you to forget this. This is a very important point. So let's let p equal to something. Now what is that something? The something is what e is raised to, which is 4x squared plus what? 4x squared plus x. Let's differentiate this. Remember, if you don't have a number on a variable, remember there's 1. So p prime is equal to the power multiplies the coefficient. So it's 2 times 4. That's 8, and the power of 2 is reduced by 1, so you get a 1. The derivative of a number with the letter having the power of 1 will always be the number that's with the letter. So plus 1. And that is your derivative of something. So f prime of x will always be the derivative of something, which is p prime, times e to something, which is 4x squared plus x. Therefore, f prime of x is equal to p prime, which is 8x plus 1 times e to the 4x squared plus x. And this will be your derivative. Alright, let's move on. Example number 7. F of x is equal to e raised to 1 over x. You can pause the video and try. Then just food for thought. Remember that every time you're learning, try to pause the video to every question that you come across, as long as you understand the main concept. Because there's actually nothing new under the sun. Everything that we learn is something that was learned years back. So we're actually on a benefit or advantage side. So let's try and get these things right. Let's begin. I'm not going to say this, but I'm just going to ask you, what's the derivative of this? If you said given e to the something, it always be the derivative of something times e to the something, then you're right. Let's get data. So what should we do? Yes, let p equal to what? Something. Then do what? Find what p is. P is what e is raised to, which is 1 over x. How do you differentiate this? Put it in a way we can understand. So p is going to be equal to what? X to the minus 1. Alright. Because if you can recall, I did make mention that if you have 1 over a, where a is the variable, it's the same as a to the minus n. If you have n, 1 over a to the n will always be a to minus n. So this implies that p prime will be negative 1, x to the minus 1, which means p prime will be negative x to the minus 2. So f prime of x will be equal to p prime times e to the 1 over x. Then f prime of x will be equal to what's p prime? P prime is negative x to the minus 2 times e to the 1 over x. You can leave your answer here to avoid wasting time. Or if you want, you can say, okay, since f prime of x is negative 1 x in actual sense to the power minus 2 times e to the 1 over x, you can also write this as this. You can say negative 1 over x squared times e to the 1 over x, which in turn gives me f prime of x to be equal to negative e to the 1 over x squared. Like that. And that is our derivative. Let's look at the last example. Suppose you have f of x is equal to negative 2 e to the minus x. You try and pause the video and try to attempt it on your own. Alright, collect data. Let p equal to something. In this case, what's the something? What e is raised to, which is negative x. This is a power of 1. So p prime will be the derivative of this, which will be, in actual sense, same as, if I even write p prime, let me put it in a way you can understand. P is the same as 1 writing negative 1x. And we know the derivative of this will just be p prime is equal to negative 1. Now, f prime of x will just be p prime times whatever you have, which is negative 2 times e to the minus x. So f prime of x is equal to p prime, which is minus 1 times minus 2 times e to the minus x. So f prime of x is the same as 1 writing minus 2 times minus 1 times e to the minus x. So f prime of x is equal to the minus 2 multiplies the minus 1, and you get a positive 2 times e to the minus x. And this is your final answer. Alright, so this is the end of this video. I hope you get a hang of it. I hope you understand. If you don't get it right, you can start the video again and try to get it right. Alright, so this is Mr. Sen. Don't forget to like and subscribe. Alright, let's try and get that A+.